Great. Well, I'd like to welcome everyone to this public presentation on hydrothermal carbonization. Hydrothermal carbonization, or HTC, is a technology that enables the conversion of biosolids, otherwise known as wastewater sludge, into useful products and possibly also into energy to make electricity. Today is January 18th, 2024, and Gardner Clean Air is hosting this presentation at the West End Beagle Club in Gardner, Massachusetts. My name is Alan Russo, and I'm co-leader of Gardner Clean Air. I'm also here with Sue Russo, my wife, who is also a co-leader of Gardner Clean Air. Included in our audience today, we do have some city officials. We have City Councilor David Moniz, Tybolt Moniz, I'm sorry, who is with us today, and we thank you for attending. And we may have another one on Zoom, so I may have to get up and admit people as we're in meeting progress. Next, I'd like to introduce our presenter, Dan Spracklin, CEO of SoMax Circular Solutions. In March of 2023, Dan and his team provided a study to the city of Gardner for a Gardner HTC facility. In July of last year, Sue and I traveled to Pennsylvania to tour the SoMax HTC facility in Phoenixville. Phoenixville is a city comparable to Gardner. It has a population of about 17,000. Gardner's, of course, a little bit more than that, but their wastewater plant is on the roughly the same magnitude. The Phoenixville facility that they built was very impressive. And we learned a lot from our visit. We had a complete tour of everything by Dan and his colleague, Jeremy Taylor. We want to share all that knowledge with you tonight, and also to folks that are able to view the recording at a later date. So we've asked Dan to make this public presentation of Gardner's HTC study, which was done at the request of Gardner city officials. Again, it was completed in March. There was a lot of work that went into it. There is a full study that's, I think it's a 60 to 70 page document. There's a PowerPoint presentation and an executive summary that go with it. And then we have the presentation for us tonight. If anybody wants copies of any of that documentation, I'd be happy to email it to you. Some of you that are already in Gardner Clean Air Distribution have probably seen those in my attachments that we send out periodically. Now, we're going to do the presentation with Dan. When it's completed, we'll start a Q&A period. I'll probably start with questions in the room, and then we'll move over to questions on Zoom. You can use the chat box if you're on Zoom, or take yourself off a mute at that point, and then ask your question to the room. So without further ado, I'd like to introduce you to Dan Spracklin, CEO of SoMax Circular Solutions.
Thank you, Alan, and thank you everyone for coming to this public presentation of HTC at the City of Gardner. As Alan mentioned, in 2023, we produced a feasibility study. Again, it's a pretty in-depth feasibility study, has a lot of engineering jargon in it, so I've tried to summarize it here, and I'll tend to keep it at a very high level. I'm happy to go into the details and the science or the engineering behind the process or the product itself, but for purposes of a broad audience, we'll keep it pretty high level. So I'd like to start with a little bit about SoMax. So we've been at this for about a decade. We started in a partnership with Villanova Sustainable Engineering Group. This is a program of master's and PhD level students that bring together all disciplines of engineering, so electrical, mechanical, chemical engineering, and they focus on real world problems. And I got the idea for resource recovery from sewage sludge in my prior company. So I owned a septic hauling company. You may be familiar with septic systems. Essentially, septic trucks are Uber for poo. We go to your house, empty your tank, and then we take it into and deposit it at the wastewater treatment plant. Quickly in that realm, I realized that there's a lot of inefficiencies in this process. There's a lot of value in human waste that could be recovered. These are things like carbon, nitrogen, phosphorus. So it has fertilizer value, but it also has intrinsic value in it. In addition to that, you have a lot of pollutants or contaminants in human waste. Because at wastewater treatment plants, the sewage sludge, the biosolids, they accumulate everything that comes down your drain. So it's not just human waste. It's going to be everything that comes down from grease from cooking and going down your sink to surfactants or detergents, shampoos, makeup, everything you can think of that goes down a drain ends up at the treatment plant. And then that aggregates into those biosolids. So in addition to that, you have medicines like pharmaceuticals, you have microplastics from your laundry, and you have PFAS. So what HTC does is we take care of all of those pollutants and contaminants, and we transform the material. So this journey started in 2015 with Villanova University. We've published now 9 master's theses on various aspects of hydrothermal carbonization. In addition to that, our research work, we've commercialized the product. So we've taken it out of the lab and put it into real world settings. As Alan mentioned, we do have an HTC facility in Phoenixville, Pennsylvania. That is the first hydrothermal carbonization plant in the United States. There are other plants around the world, primarily Europe and in Asia. But to our knowledge, that's the only HTC plant in the US. So we've also entered some challenges and won awards. So this is to show you the variety and the flexibility of hydrothermal carbonization. We won an award for the manure challenge. So that was to how to valorize dairy manure. In 2019, we were awarded that contract from Phoenixville to build the plant. And then in 2021, after a 2-year-long process, we were selected as the grand prize winners of the Water Resource Recovery Prize by the U.S. Department of Energy. And that product was looking at seeking scalable and repeatable solutions to double the amount of resources that could be recovered from small and medium-sized wastewater treatment plants. So in DOE terminology, small and mediums, anything less than 50 million gallons per day. Most of those facilities do not have any resource recovery. So we went up against a whole slew of technologies. It was vetted by engineers, by experts at the U.S. Department of Energy, as well as we had to go through and prove that it could be financially viable for small and medium communities. Also in 2021, we were the winner of Diageo's Low Carbon Heat Challenge. Diageo is one of the largest alcohol brands in the world. They own over 240 brands. So everything from Bailey's Irish Cream to Guinness to Don Julio Tequila, just about any category of alcohol, they own brands in that. They were looking to close the loop and to make their facilities more sustainable. So with that challenge, we were able to prove to them that we could take the stillage from their distillery and meet 100% of the thermal energy demand from those waste grains. And then early in January of 2023, the PXV Neo, which is a municipal branded plant, HTC plant, came online in production. So what is hydrothermal carbonization? This is a really simplified graph, but you can take any organic waste material, put it into an I'm getting some feedback, Alan.
Yeah, I'm hearing that also. If you could please mute your phone, your laptops or your smartphones. Bob, I think it's coming from yours. I'm going to mute you, okay? Yeah.
Okay, I think that took care of it.
Yeah.
So what do we do with hydrothermal carbonization? Again, you can put any organic material in it. So it could be food waste, it could be manures, it could be human waste, it could be leaves and lawn clippings as well. And what hydrothermal carbonization does, the advantage is we process the material wet, meaning that we don't have to go through the energy intensive process of drying the material before converting it. So in the presence of water, and the water is the moisture content of this material. So biosolids or sewage sludge is typically anywhere from 5% to about 30% solids. The rest of that being water content. We heat up the material to between 180 and 220 degrees Celsius. At Phoenixville, we target 200 Celsius, and that would equate to 400 degrees Fahrenheit. So what you would bake cookies or a frozen pizza in your home oven. We're not talking about industrial heat. This is the same heat that everyone has in their kitchen. And we put the material under pressure. Water does a unique thing under pressure. So when you heat it up, it does not convert into steam like it would in a stovetop and boiling water for making pasta. It goes into a subcritical state. And that subcritical state triggers is a reagent and triggers all the chemical reactions to occur. And what happens is you have larger chain molecules. So think of like a carbohydrate. It's going to be carbon and hydrogen bonds, or a sugar that's going to be carbon hydrogen bonds in 16 to 18 to 34 chain length. We break those bonds. We smooth out the edges of that product. We're driving off hydrogen and oxygen groups. And then we reassemble those compounds. And then you have a more stable compound after this. So this is thermochemical treatment. It's not biological. It doesn't require bacteria or bugs like, say, anaerobic digestion would. And all of this happens very quickly. In comparison, so this can go from sewage sludge anywhere from 30 minutes to 3 hours. If you're putting in food waste, you're about 2 hours. If you're putting in more like twigs and branch and lignocellulistic material, it would take about 4 hours. To compare that to like anaerobic digestion would take 2 weeks to process that material. If you were to compost this material, it would take 12 weeks, so about 3 months. And in places like, the Mid-Atlantic and New England, right now, no one's composting anything. It's just too cold out and the bacteria die. So in this process, we get 2 products out of this. We get a biosolution or a processed water, and that will have most of your nutrients in it. So it will have all the soluble compounds like nitrogen in the form of ammonia. So there you have a liquid fertilizer. And then we also have the solid product, hydrochar. And both of these products have multiple uses. But generally what happens is any of your heavy metals, any of your non-minerals will stay on the hydrochar, and any soluble compounds, so salts, organic acids, nitrogen, for example, will migrate into the biosolution. So you have the ability for selective nutrient recovery here as well. So very basic, very high level understanding of what hydrothermal carbonization is, and let's go into what does it actually mean. So we did in our feasibility study a comparison. So the other option was landfill expansion, which I'm assuming everyone in the room and everyone on the call here has experience and knows what that is. So what we did is we looked at direct comparison between the two. We have certain metrics up here. You'll see them in the table there of the lifespan, the footprint, the cost to date, the expected year zero costs. So that's all the money that's upfront before you can actually start processing. And then we focused on 20 years from now, what does it look like? So with this, the sludge landfill will decrease with Gardner's growth and development. You have a fixed process here. It's expected that this expansion would buy you basically another 17 years. HTC and gasification to make energy, those plants are on average 30 years plus in lifespan. Again, a much smaller footprint, so from hundreds of thousands of square feet to 10 to 15,000 square feet, with the majority of that being allowing for truck traffic to move around. The HTC system itself is less than 5,000 square feet. It's pretty compact. The cost was 28,000 for the feasibility study versus 1 million for the landfill expenses to date. So the big one is looking at, what does it cost year zero balance? We're looking at 7 million for the landfill and 5 to 6 million for HTC plus gasification. That's with the Inflation Reduction Act. We'll get into that later. But then we wanted to fast forward, and what happens after 20 years is you see that the landfill costs increase to around $9 million. Whereas the HTC has already returned its initial investment, and then you have a surplus of $10 million. HTC would allow for the growth of Gardner sludge, and you're only taking up, so Gardner would only take up about 21% of the design capacity of a full-scale HTC system. The remaining capacity could be filled with hauled waste, where Gardner would actually generate revenue by accepting biosolids from other communities within Massachusetts. So Massachusetts and New England has a big biosolids issue, and that is that there's really not a lot of outlets for it, and most of the material is trucked out of state. So you have pretty significant costs for municipalities in central Mass, averaging between $100 to $200 per ton of disposal. So we have, there was a concern that city officials had said is, we don't know that there's enough material out there. So we set up a meeting with Veolia, their Northeast biosolids manager, and he verified that there's plenty of biosolids in the region, and you would be able to generate revenue. So not a concern in filling up capacity. The concern would be you'd actually have to turn some folks away and not be able to participate in this program with just one HTC system. Again, many municipalities are taking their biosolids out of state, either to Connecticut or to Ohio, and they're being incinerated in those places in Connecticut, and then in Ohio, they're being land applied. So this is just a graph that shows kind of the difference in economic outcomes of the two options. The blue line there representing hydrothermal carbonization plant, and the orange line representing the landfill expansion cost. You'll notice that dip from 17 to 18 years, and that's the closing costs of the landfill that are added on. And you'll see that the landfill costs, it never returns on the investment back to the ratepayers of Gardner. And then you see a breakdown of the costs associated with these two options. So pretty close in total, 9.6 million and about 10 million for HTC plus gasification. However, with the Inflation Reduction Act, which is get into on the next slide, the total cost all in and said done would be reduced to about a little over $6 million. And that's due to federal tax incentives that would potentially qualify HTC plus gasification for. So what do those incentives look like? This is based on the Inflation Reduction Act that was signed into law by Congress in 2022. So it establishes tax incentives and credits for renewable energy projects. So any projects that's bringing in net new renewable energy to the United States. The one unique thing about the Inflation Reduction Act is that it allowed for the first time non-taxable entities like tribes, municipalities, and nonprofits to qualify for federal tax refunds and federal tax credits. So if this were to go through to qualify, you would be able to, the city of Gardner would actually file a federal tax return and receive a check back from the US government and the IRS. I am not a tax advisor, and this is not tax advice, so I would expect city council to reach out to state representatives. They can help you through the ramifications of the act and determine qualifications of it. But there's a base credit of 6% of the overall project cost. So that's unique. It's the overall project cost, not just the capital equipment, not just the construction or engineering, but everything that's said and done for that project can qualify for a percentage off or a tax incentive and a tax credit. So if you're producing renewable energy, you get 6% automatically. That's the base credit. And then there are some bonus credits. So one of them would be if you're using contractors that pay prevailing wage and then they have an approved apprenticeship program. That gets you a 24% bonus, bringing your total up to 30%. If the project uses domestically produced iron or steel, and it's got to be 55% of all the iron or steel in the project would qualify for an additional 10% bonus credit. And then there's a final bonus credit for energy communities. And this is based on retired or closed coal power plants or coal mines. The EPA has a map showing what areas and communities qualify for this. We checked out Gardner, and unfortunately, this is not applicable for Gardner. So the max that you could potentially receive as a tax credit would be 40%. You couldn't quite get up to that 50% because of the location, and you're not a energy community that's been impacted by coal mine or coal power plant closures. So what are the benefits of putting in HTC for the city of Gardner? The first one is regulatory risk. You're no longer landfilling biosolids. All it would take would be for a new regulation to come from either Mass DEQ or the state legislator to outlaw landfilling of biosolids. One of the things to pay attention to is PFAS, or these forever compounds. Not only is Massachusetts looking to try and solve this issue, there are a lot of states, but the federal EPA, Environmental Protection Agency, came out in 2022 with regulations on drinking water. They have indicated that 2024 they will come out with new regulations on wastewater and biosolids. And unfortunately, we didn't test for PFAS, but I can guarantee that PFAS is in Gardner's biosolids. And the reason why I can guarantee that is that every biosolid sample that's been tested for PFAS has shown tested positive for PFAS presence. Now, the percent and the strength of the PFAS varies, but every single sample of biosolids that's been tested in the United States has tested positive for PFAS. And that's because PFAS is in everything. It's in your McDonald's wrappers, it's in your clothing, it's in your carpets, it's in your makeup. It's just about touches everything that we do. And unfortunately, it is a forever chemical for a reason. And that is because there's no natural way to break that fluorine and carbon bond in environment. So they literally stick around forever and they do not degrade in the environment. The other benefit is you're, again, turning a liability into an asset. Right now, biosolids management for the city of Gardner is a cost item. It's a constant cost, whether you're sending it to your own landfill. There is a cost associated with that. If you're sending it out of state, like other municipalities are, there is a cost for that, and those costs are only going up. When we looked at biosolids disposal rates for a little over a dozen communities in Pennsylvania, the average cost increase was 6% year over year over year. So every year it's a 6% increase. So those costs are only going up. It's never going to go down. Beyond that, you have the additional capacity to process solids. So you now turn your wastewater treatment plant into a revenue generating center. It can, again, take in hauled waste from other municipalities, charge that tipping or that gate fee to those municipalities for disposal, and generate revenue for the city of Gardner to not only pay back the ROI on the investment, but to build up a healthy fund balance for projects in the future. And then again, up to 40% cost coverage of the project with the Inflation Reduction Act. So our recommendations and next steps for the city of Gardner were to reassess usage rates of ferrochloride and polymer at the wastewater treatment plant. I believe they have now reduced their ferrochloride rates. We were able to identify that in our study. And I think they've reduced that usage and saving Gardner money on the consumable ferrochloride. The other thing we've suggested to city officials is to assess local and regional market potential for hauled waste availability and tip fees. Again, reach out to the Veolia Northeast Biosolids manager, and he can tell you exactly what everyone's paying and the volumes that they're producing. And again, he's verified that there's more than enough supply to meet the capacity of a Gardner HTC system. The other thing we asked them to do is explore and evaluate state and county grant opportunities and energy production subsidies through the public utility. So at Phoenixville, at the plant there, we were able to secure over $1 million in grants, $400,000 from the county, $600,000 from the state. In addition to that, the utility provider in Pennsylvania, PECO, has a program that will pay up to $2 million for energy demand removed from the grid from industrial users. So they will actually pay the city of Phoenixville 14 cents per kilowatt that they don't consume from the grid and displace with their own renewable energy that's produced via gasification. And then the next step was to actually move into a formal engineering and design phase for implementing HTC at the city of Gardner. So with that, as a quick high-level introduction, I'm happy to take any questions you may have.
Hey, thank you, Dan. That was really an excellent overview. We did have one question that popped up from Zoom while you were delivering, and it was from Jim Boone. It was a question relative to what is PFAS. Maybe you could say a few more words about that.
Yeah, PFAS is a generic term that refers to any poly and perfluoride compounds. So these are typically flame retardant and non-stick surface materials. So think of your Teflon pans. When you cook on those, PFAS is what's on those pans to make them non-stick. In your carpets, anything Scotchgard that prevents them from staining. Scotchgard is another PFAS product. The other big one is going to be in pizza boxes and wrappers. So the hamburger wrapper from McDonald's, for example, has PFAS on it so that the cheese and the ketchup doesn't stick to it. And finally, the third big one would be in your makeup. Makeup foundation has a lot of PFAS in it. So PFAS is, again, a catch-all term for over 5,000 different compounds. PFOA and PFAS are the two main ones of concern. And the reason for concern is they bioaccumulate in your body. You ingest this through food, through water, and they do not leave your body. They end up building up, and they have all sorts of health implications and ramifications from it.
Thank you, Dan. Okay, I'm going to open it to the audience here in the room, and we have quite a large crowd here at the West End Beagle Club. So if you'd like to ask a question to Dan, please raise your hand. Yes. You won't hear it except for me. Thank you. Okay, questions?
How long has the plant they did build been running?
It's been running for a year. So it was started up in production in January of 2023. We've had pilot plants running for the last 8 years. The first commercial HTC plant was built in China, actually, and that's been running since 2016. So the technology is relatively new, but the thing is that it's chemistry, so it happens, under the right conditions. And in our feasibility study, we do have pictures of the plants, but abstractly, the plant equipment is pipes, pumps, and tanks. So, for example, our reactor is a serpentine pipe reactor. There's no moving parts in that reactor. So, yeah, it's been a year, but the technology's been around for about 15, 16 years. And then in operation commercially for about 8 years in China. And then, like I said, we've had a pilot plant running for about 8 years ourselves.
Very good. Thank you. There's another question. We do have some online too, but if you have another question.
Is there a high demand for the byproducts from the plants?
There is. So the product for, let's go with the biosolution first. I mean, the first thing you could do is a liquid biosolution, but you're trucking water, so it's not really ideal. What you would do is we would create what's called ammonium sulfate. Ammonium sulfate is a fertilizer that's used at golf courses and turf facilities all over the world. There's a huge demand of it from the golf community. And the hydrochar, again, if you are using it for gasification, you're going to use it to produce energy, and it will have just ash left over. The hydrochar also can be used as a carbon sequestration event by used in building materials. So we can put it into concrete at ready mix facilities and then concrete aggregates. So it replaces a fine aggregate of sand in a concrete mix, and it lowers the carbon intensity of the concrete. The federal government has a Buy Clean initiative, which they will procure and purchase low carbon products. And the largest consumer of concrete in the United States is the federal government. Some other states have enacted low carbon concrete legislation as well. So New Jersey has. The state will require low carbon concrete in all state funded projects. And they've included that a carrot with that is those suppliers of that low carbon concrete qualify for a reduction in their state taxes on all of their income and not just the income for that specific state funded project. So ready mix facilities would be willing to take this on. In addition to that, we've done now 3 rounds of testing with CertainTeed. CertainTeed is a roofing shingle manufacturer, and they've used the hydrochar from Phoenixville in their roofing shingles. They have come back to us with 2 questions. What's the carbon negativity of the product? And how much can you produce? So CertainTeed has a production facility, I believe in Massachusetts, but don't quote me on that. And they would be looking to procure this material because, again, they're looking to lower the carbon intensity of their roofing shingles.
Okay, very good. There was one question that came in that popped into the chat box from Aaron Keywell, who is on Zoom, and that was, what is the time frame from starting a HTC facility to finishing and bringing it online?
Well, that should have a simple answer, but it's not quite so simple. There's a lot of variables in it, but I'm going to go with a happy path. Let's assume that everything is approved. Let's say it got approved on January 1st of 2024. In June and July, the equipment would start showing up. And then you have about 3 months of construction and about 2 months of commissioning and training staff and doing the handoff. So by November-ish, December of 2024, you could have a commissioned, completely commercialized running HTC facility. Where there's some hesitation there is not knowing exactly where this is going. Do you have the concrete slab poured? How long would that take? Are there any zoning issues associated with where you're going to put this? Those are things that could add to that timeline. But strictly from signing a purchase order or a contract to commissioning, you're looking about 12 months.
12 months. Thank you, Dan.
Mhm.
Other questions from people in the room? Okay, I'm going to hand it over to Thomas.
Does the money that comes back from SoMax to the town, is that at will for the town to have the money to use for whatever they want? Or do the taxpayers get some subsidy for the fact of their water and sewer?
So in this scenario, the city of Gardner would be purchasing and owning the plant. So SoMax would not have an equity or an ownership stake in the plant. So how that money is apportioned would be up to elected officials and city councilors and your mayor.
Oh, so that's a open checkbook then. Maybe you can buy more scooters.
Yeah.
In Massachusetts, all revenue is general revenue. Unless otherwise specified in Mass General Law. I used to work for Department of Ed and Department of Local Services, DOR. The one thing I'm not sure, and I don't know if city councilors would know this, do you know if you're currently your solid waste system, your landfill is an enterprise fund? Therefore, the revenue, would you know that?
Yeah, it is an enterprise fund, the solid waste landfill. It's not, we don't have a landfill there today. It's been closed, but it all runs through a transfer system and we do pay rates for that. Yeah, and the water sewer is the same way. Right. So yeah, and essentially, you know, we pay for sewer, we pay $5 per cubic foot. And I don't recall the water rate, but we get those in a quarterly bill along with a trash bill for that quarter. That's like 50 something dollars. The opportunity here is, and I say it's an opportunity, have to be determined by city officials, the city council and the mayor, is with that money you're getting back from tipping fees and if you generate electricity, there'll be some savings of electricity every single year. Can go into possibly lowering sewer rates. Now, that's a novel idea. I'm not predicting tax decreases for Gardner, even with $10 million of profit in 20 years. Because this thing is generating, I've looked at Dan's spreadsheet behind the calculations on that graph that shoots up to roughly $10 million. And it's roughly $900,000 a year of net revenue into this particular project. So rather than spending money, burying the stuff in West Gardner or hauling it anywhere else, you're actually got a process that can actually generate revenue. But it will be, I think it will be up to city officials to determine what to do with that revenue. And, you know, whether it stays with or a general fund or enterprise, as Mary Jane Handy said, you know, based on her work in the past. So, yeah. Any other questions? If you could just call your name off.
Old Mayo. Dan, thanks for the presentation tonight. PFAS, it's a major concern here in north central Massachusetts, specifically with the bordering town of Westminster, who there was a company that imported paper waste from the Seaman Paper Company, and they were processing the paper waste along with other products into fertilizer. And what happened was all the private wells in a large area of Westminster have now been contaminated with the PFAS. Now, when your company came in and did the study for the city of Gardner, why, this is a twofold question. Why wasn't a study done of Gardner's present sludge and the percentage of PFAS within the sludge? And the second question would be, with the HTC process, what does that do with the PFAS? Is there any way that PFAS is eliminated through any chemical, mechanical process, or is PFAS going to be part of the product, the final product that is produced through the HTC process?
All right. Thank you for that question. So to your point, one of the major sources of PFAS contamination and spreading into the environment is through the land application of sludges, biosolids, paper mill sludge, etc. The real big issue is when it gets into the soil. It's almost impossible to remediate it out of the soil. PFAS in water is a much easier way of treating it. Basically, one of the foremost ways of doing it is through activated carbon filtration. The other way is through reverse osmosis. So I would expect that probably, Westminster would follow the steps of some other affected communities, primarily in North Carolina in the Cape Fear region, where they've actually installed reverse osmosis systems in all the homes that are affected by PFAS contamination. So that's first. The second part of your question, what does HTC do? We don't quite know exactly yet. There's literature out there that says that HTC actually reduces, but does not eliminate PFAS. What in that study showed, or the flaw with that study, is they didn't look at the process water biosolution of that. So part of it could be put into that biosolution, but again, putting PFAS into water is not the worst case scenario, because an activated carbon filter that process water goes through can remove and capture that PFAS. There's also some interesting research being done on biochar and hydrochar and their ability to actually capture and absorb PFAS from water. So HTC itself will not destroy it, because we don't get high enough temperatures and retention time to destroy those carbon fluorine bonds. However, if you were to implement gasification does have high enough temperature and long enough retention time, and has been proven to destroy PFAS. So it's an if and. We lower the concentration through HTC, and then we completely eliminate it through gasification. The other aspect of it is if it was to go into, say, like a concrete additive or a aggregate, the sand replacement. The hydrochar would absorb the PFAS and then be encased in that concrete, and theoretically should not reach out. I say theoretically because we haven't done and no one's done any testing on the leachability of PFAS out of concrete blocks. But logic would tell me that it's sequestered and locked up into that concrete and not going to leach out into the environment. But the safest way, and if you wanted to prove PFAS destruction, would be go through the step of gasification. So gasification and pyrolysis have been proven not only in the labs, but in real world exercises to destroy PFAS compounds.
All right, Dan, thank you for that. Gardner is actually fortunate that we do have a concrete producing plant within like a mile or two of the current sludge processing plant. So, we've got that right there. But I want to go back to the question again. Has Gardner tested for PFAS in their sludge?
To my knowledge, no, they have not, because it has not been required. And it's not unique to Gardner. A lot of municipalities don't want to test for PFAS because ignorance is bliss, right? If you don't know that you have it, you don't have to be concerned with what's happening with your biosolids. So it's not unique to Gardner to not test it and not to want to test it until it's required. We see that playing out in communities all over the country. So to my knowledge, and again, they may have tested it separately, it was not within the scope of work for the feasibility study. And to my knowledge, they have not tested the biosolids for PFAS.
I can try to help answer part of that question. Can you hear me, Dan, on your end?
Yes.
Okay, very good. There was a state requirement to start testing sludge for PFAS this year. But I think due to the logistics and I don't know, maybe cost, I'm only guessing, I think it's been delayed. My queries to the DPW and the water sewer department have been around, where are we with PFAS testing? And what I've been able to ascertain from information I've gotten back through public records request is I think it's been delayed, but I don't know where it is right at the moment. But the state is looking for PFAS testing of sludge. So that is and I can only expect, there's some expense involved with doing that type of testing, and that could be why some of the delays have been put in place for that. So, thank you. Other questions in the room? I think we have one.
Hi, Dan. Thank you for your presentation. Terry Griffiths. I was wondering if there are any toxins produced in the hydrothermal carbonization process or gasification, whether liquid, solid, or off gases, and how do you dispose of them or make? take
Yeah,
care of
so
them?
in HTC, there are no harmful byproducts produced through the process. There are emissions associated with the process. So roughly 4% of the carbon that's in the feedstock material in the process will convert into carbon dioxide. That carbon dioxide is released in the step when we start the dewatering process. So you are releasing CO2. Again, not necessarily a harmful product. Might catch a lot of flack from this, but we do need carbon dioxide in the atmosphere. The problem is that we have too much of it in the atmosphere because we've been digging up carbon for the last century that's been sequestered for hundreds of millions of years in the form of coal, oil, and natural gas, and burning it to release more carbon dioxide in the atmosphere. So the emissions associated with gasification, you will have carbon dioxide emitted through that. Those emissions are categorized as biogenic carbon dioxide emissions. And so the easiest way to think about that, the difference between anthropomorphic, which is man-made, and biogenic is, think of a forest. So in the spring, the forest grows biomass in the form of leaves. And then to grow that biomass, it's sucking out CO2 from the atmosphere. In autumn, when those leaves fall to the ground and they start to decay and degrade, they release that CO2 back into the atmosphere. These are biogenic or naturally occurring emissions. Since the carbon in the feedstock material of HTC is captured from the environment, when you do gasification, you're just releasing it back into the environment. Gasification also, HTC plus gasification actually lowers certain emissions. So SOx emissions or sulfur oxide emissions or nitrogen oxide emissions, NOx. You often heard the term NOx and SOx. Nitrogen, again, being pushed into the process water lowers the amount of nitrogen in the hydrochar. And then the same for sulfur. Once we do a cold gas cleaning process where we scrub all of that. So there is no NOx or SOx emissions associated with gasification, or if there are, they're de minimis, they're very small. I can tell you that in Pennsylvania with the HTC plant, we were not required to receive an air permit because the CO2 emissions were well below the thresholds of requiring an air permit in Pennsylvania. I can't say the same necessarily about Mass because I'm not quite familiar with Mass's air regulations. I'm sure there's someone in the audience that would be more familiar with that than I am. The only really thing that it's not a hazardous compound, but there is a distinct odor with hydrothermal carbonization in that the hydrochar smells a little bit like burnt coffee or burnt chocolate. And that is the result of nitrogen compounds being caramelized. So if you ever grilled a steak and you get that charring on the steak when you have the temperature too high, those are proteins breaking down into amino acids and nitrogen. And these are called Maillard reactions. So are they hazardous? No, but there is a distinct odor with it. I think Alan has some samples of the hydrochar from Phoenixville. I would highly encourage you to smell those. It does not smell like human waste. I'll tell you that right now. It does smell more like the typical response is burnt chocolate or burnt coffee. But beyond that, no, there are no hazardous compounds created in this process.
Okay, thank you, Dan. And I did pass around 2 bags that I had brought back as souvenirs from our trip to Phoenixville. And tell you, consistency is somewhat like a coal substance. Odor is, as Dan said, it's not the sludge odor. Anybody that's been out in the sludge landfill area knows what sulfur dioxide smells like, which is really a harmful gas in a confined area. So this completely transforms this process transforms the chemical nature of the wastewater sludge, which is remarkable.
I'm sorry, I had one more part to my question.
Okay,
One
go
more
ahead.
question. Would you work with the town for placement of the facility? I know that Gardner has its own zoning, but I'm sure that, you might have recommendations.
Yeah, we've talked to them about placement. I think they have selected a property that is owned by the city of Gardner now. That was kind of their ideal place for this. But again, we have not really had any interactions with city officials since March of 2023, once we delivered the report. But yes, we would work with them to select the appropriate places to put this. We don't really have a dog in that fight.
Okay, thank you, Dan. Question over here. Oh, yeah, we did have a chat question. I'm going to go to the chat question, Dan. And Aaron on Zoom asked, can the Pooh Mountain that's currently in West Gardner be run through the HTC facility? I think we want to get rid of the Pooh Mountain that's out there already, let alone make it larger. So,
technically, yes, it can run through there. It's just, has that decayed in the anoxic environment of the landfill. Would it be a good quality biofuel at that point? You would just have different effects of the characteristic of the hydrochar. But the simple oversimplified answer is yes, it could be processed through the HTC system.
oh, thank you.
A rule of thumb would be anything that's organic in nature can be processed. So we process some things like off the wall, like t-shirts, jeans. We've taken some denim and processed that. And the cotton in both the t-shirts and the jeans will carbonize.
We have 2 people looking at, he's yielding to Vicky.
My question is, what does Gardner have to do to be producing what it takes in order to get a benefit from the credits, the IR?
The
whatever.
Inflation Reduction Act credits, all they have, there's no threshold. You just have to be producing net new renewable energy. So that would require gasification to be part of the project, and then that would be the qualifier. Again, I would encourage the city of Gardner elected officials and city workers to work with their local liaison office to Massachusetts senators or representatives, because they would walk them through that process and through the bill, since the liaison office had a hand in crafting that bill. And if they didn't, then they have access to the experts that actually wrote the bill. That's where I would suggest that Gardner officials start contacting your local state liaison rep.
Thank you, Dan. We have another question from the room.
Hi, thank you for the presentation. David Tebow Munoz. I'm a Ward 1 City Councilor, newly elected. Question about, I wanted to hear a little bit more in comparison to the plant in Phoenixville and the pilot plants, in terms of a few questions related to that in comparison to what's proposed for Gardner. One is, is there sludge being transferred in from other locations at any of the pilot or the location in Phoenix? And 2, in terms of the amount of energy that can be created through gasification for Phoenixville, is that being used? And how vast is it? I mean, would it be enough to fuel municipal buildings, or is it more than that?
Yeah, so Phoenixville has not chosen yet to do gasification. We did that project in 2 stages. The first one was to do the HTC process, and then the second phase is to do 2 things: to bring in food waste and to convert to gasification, because food waste has higher energy density. But we did do in the feasibility study, we showed a mass and energy balance, which showed that at capacity, through gasification, we could not only power the wastewater treatment plant completely, but there'd be an excess of megawatt hours of energy available to other municipal buildings. Off the top of my head, I don't have that number. I'd have to refer back to the feasibility study because we did publish that almost a year ago, and we've done several since then. The pilot plants always bring in different material. So we're bringing in cow manure, we're bringing in sewage sludge from different municipalities. Phoenixville it is getting ready to accept hauled waste in the form of septage, but not in the form of biosolids. It's the way that they're set up, their specific plant. They don't have room to put in a solids receiving bay. So everything that comes to them is coming in more of a liquid form, if you will.
Thank you.
On that point, we started with a project with a regional facility here in Montgomery County, Pennsylvania, which is northwestern suburbs of Philadelphia, where there are 6 communities coming together to build a facility. And that facility will take in the material from 3 different wastewater treatment plants. So 3 sludges coming combined to that regional facility. The one proposed in Gardner would be almost the exact duplicate of the Phoenixville plant in size, and in sort of layout and process. I think I answered all your questions there. If I didn't, let me know.
Sorry, where did you say the one that's going to be transporting in wastewater? Where is that located?
That's in Montgomery County, Pennsylvania. So it's if you're from King of Prussia is the name of the town. It's a northwest suburb of Philadelphia. It's about 20 miles due west northwest of Philadelphia, Center City, Philadelphia.
Okay, thank you.
Okay, thank you. Other questions from the room or? Okay, let me get the microphone over. Thank you.
Thank you. My name's Jim Russo. And thank you, Dan, for your time this evening and this really eye-opening presentation. I think some of those slides with those numbers on there, I mean, this just makes a whole lot of sense. Makes a lot of sense for the now, for the near future and the far future. We're not just talking about us dealing with this, but kids and our kids' kids. This is helpful to them. So we're really doing something here that can help Gardner for years to come, not just potentially a 17-year plan with no other solution foreseeable after that. So more or less a dead end road with a lot of money spent. So I just wanted to ask, it's been mentioned tonight there was a feasibility study done. So just to kind of wrap my head around this, the city of Gardner contacted you to do a feasibility study? Is that more or less what happened?
Yeah, actually Veolia. And so the city of Gardner, they have Veolia manage operations of the wastewater treatment plant. The treatment plant superintendent reached out to us and contacted us directly to ask questions about HTC and, see what we could do. So we put together a proposal for the city of Gardner. They accepted it, and we delivered that report again in March of 2023. Since then, there's been no contact from any city officials, anyone from Veolia in the operations side. We have had some other folks from Veolia contact us about other properties and other solutions in other municipalities in other states. But it's really been kind of thanks for the report, and it's collecting dust. I did watch a city council meeting or committee meeting where Public Works Director basically said they did the HTC plant to fulfill a requirement from the state that they look at alternatives. And so treated more like it was checking a box. But yeah, we haven't had any really interaction with anyone from Gardner outside of Alan and the Clean Air team.
Well, I guess I'm a little disappointed to hear that. There's just so much opportunity here. And we've covered just a small bit of it, I think, tonight. But basically, I mean, this stuff is just being basically thrown in a hole in our town, in our city, and just to sit there. Whereas there's an opportunity here with this technology. We're actually at a point, it seems, with this technology that you're on the cutting edge with, that, you know, we can take this waste that we didn't really know what to do with other than to dig big holes and throw it in the ground. We can actually further process this to the point where we're minimizing the environmental impact and possibly produce energy. In the feasibility study that was done, samples were sent to you.
Correct. Yes, we did accept samples from the sludge from Gardner's wastewater treatment plant. The other one thing I will say that came out of this report is we identified that they had a very high ferrochloride use, and so we recommended they reduce that. And I've been told that the city of Gardner has acted on that recommendation and reduced ferrochloride use in the treatment plant.
So
But,
did this?
yeah.
Okay. So did the samples suggest that we could get like the gasification needed to do power generation?
Yes, so it showed a positive energy balance. It would show that it would power the wastewater treatment plant, and then there would be some actually excess energy. Again, I don't have those numbers off the top of my head. I'd have to refer to the study, but it is in that study. You should have access to that study through city officials. If not, you know, a Freedom of Information request would produce that study for you.
I just see this as such an awesome opportunity where we're basically able to deal with this problem in a much better way, a much more long lasting way, better on the dollar way, the long-term benefits, and we can create power that can power the wastewater treatment plant and municipal buildings at a minimum in the city of Gardner. I'm from the solar industry, and this is a process called net metering. So basically you would take there would be essentially a meter, power meter at this facility. This would produce energy. It would send energy credits to the utility, and that can be dispersed to wherever you'd like. A lot of solar farms work in this manner. Even residential solar systems work in this manner. So he could literally, with this plant, allocate the energy credit being created here to the meters that are on these municipal buildings. So that's how the power gets there. So that's how we can literally target the energy that is being created here to exactly where we want it to go in Gardner to help really reduce overall cost even further. So I think that's, it just seems like a no-brainer to me. So I hope that, you know, with the public getting more information like tonight, you know, we can go to our ward counselors and really have them pay more attention to this, because this just seems to make all the sense. Thank you very much.
Yeah, the only thing I would add to that is that the other thing that's different is this is what they call clean firm energy. So it's not intermittent. This is energy that's produced 24 hours a day. So it can go and solve problems that, you know, solar and wind couldn't do. So it can run street lights at night. It can run stoplights throughout the day. You know, anywhere you need power, this is dispatchable power 24/7, often referred to as clean firm. So just wanted to throw that out there as well.
Okay, we have a question from the back of the room here. We're going to hand the mic back, pass it back so you can hear Dan.
My name is Thomas Russo. The gasification to energy piece, what that's going to be an additional cost. what's that cost in the process of building the plant? And then how long does it take the saved money for buying electricity? How long does it take to offset the cost of building the gasification to energy plant?
So the gasification is included in that $10 million number. It's actually broken down in this presentation. So this shows it's in that $8 million number. It includes the cost of gasification. If you were looking at just energy and savings in electrical, it would be quite a bit for it to pay back, because Gardner pays, again, bear with me here because I'm trying to remember from a year ago, around 8 to 10 cents a kilowatt for energy. So you're also, really the payback on this is through the revenue from the hauled sludge from outside communities and those tip fees. That's what really drives the economics of this. If you were looking at this as a purely energy play, it would take quite a while for this to return on investment. The other thing that's been suggested in the feasibility study is to work with the local utilities, because there are some renewable energy and energy efficiency programs that are mandated by state legislation. So again, here in Pennsylvania, PECO is the utility, and they will pay Phoenixville. Not only is Phoenixville saving the 8 cents that they pay per kilowatt, but they will pay them 11 cents per kilowatt not to use energy. So it's a net outcome of 19 cents per kilowatt. But the energy is not the economic driver of this. It's, again, those tip fees and the hauled waste sludge from the outside community. But you benefit from, you'll need that to produce energy. If you were just to use Gardner sludge, you would not be able to produce enough energy to run the wastewater treatment plant, because you're, again, only about 20% capacity of the system.
Okay, we have another question from the room, Dan.
Hey, it's me again. So in terms of the proposal for Gardner, in terms of the cost of building the plant, does that take into account, the various the creation of the various products, like, the concrete you were talking about, in terms of the products that would be used to create the concrete, create shingles, to create multiple products? Is that just like a sort of like, it could also do this if you expand it in this way, or like, how does that?
No, it creates the hydrochar product, and then the hydrochar product is then sold to an industry that manufactures shipping or roofing shingles or concrete. There's no concrete plant going in with this, or roofing shingle plant going in with this. These are existing industries that you're selling, so you're basically making a raw material for those industries to use if you didn't want to pursue gasification.
You say it's an instead of gasification?
Yeah, so it's
One or the other.
options, either or. You can make energy from it in gasification. If you gasify it, then you've used up that hydrochar. The only thing that's left is ash. If you didn't want to do gasification, you would have that hydrochar that could then be sold to ready mix facilities in the concrete industry, or sold to Certainty for roofing.
Oh, thank you.
All right, thanks, Dan. Do we have any questions online? If you would like to ask a question, just take yourself off mute. And I see Jim Boone is off mute. So do you have a question, Jim?
Yeah, Alan, couple questions. And I want to comment, and again, thank Dan as well. And as Jim Russo just said too, when Alan presented this to me, it seemed like a no-brainer. And I tried to bring it up to the city council to have them get a presentation, but that was unfortunately shut down. So I'm very happy that Alan and everybody else is getting together to hear about this. I guess my question for Dan is, like us hearing this, why isn't everybody jumping on board? Do you have a sense for that? Is it too new? And I get the feeling that even Gardner representatives also said, well, we don't know if it's going to really work. And uh, it's almost like, well, it's a change. And we've always done sludge landfills, so we're comfortable with that. And I even heard that they said, well, if we try to go down this road and it doesn't work, then what do we do? Because supposedly we've got things in the work where we got approval for the sludge. But if we start going down this other road, does that prevent us from being able to use it in the event that this particular HTC does not work? And I know I'm asking a lot of questions, but one final thought or thing to bring up, if it didn't work, is there any contract or guarantees or anything like that to go along with that? I asked too many questions at once. I apologize.
So let me start with the basic question everyone's asking. It's not a question if it works. HTC works. It's a chemical process. This is like heating up water in a water heater, right? Water heaters work. We've proven this not only for 8 years at a pilot scale, we've proven it for over a year at commercial scale.
What?
It's not just
Oh my
us.
God, that's what you came in here for? I'm gonna
All
light
right,
it
I'll
in
just
a
try
minute.
to mute that.
Are you fucking?
So it's not just us. Again, there have been over 5,000 research papers from universities all over the globe that have all proven hydrothermal carbonization of different feedstocks material, proven the economics of it, proven the LCA, proven the efficiency of it. So it's not a question of will HTC work. In fact, we would go in and we would provide some performance guarantees if that was necessary. But it works, right? It's just like does a water heater work? What we're seeing is we have interest from every state that knows about this technology. The problem is that the wastewater treatment plant is a relatively old industry and it's aging. And so practitioners are aging out, and there's going to be a huge labor issue in the wastewater treatment plant industry over the next decade. The average age of a wastewater treatment plant operator is 62 years old. When you get into some folks that are operators that are 62 years old and they've got 3 years to retirement, they're not so interested in taking on a project that would change things. They're happy to send it to a landfill, send it to land application, all of that. We have interest from 5 different states right now in the United States because those are the states that are aware of it. The problem with HTC is it hasn't really got out of academia into the real world. You don't see commercials for HTC on TV. You don't have HTC lobbyists like you do anaerobic digestion and biogas lobbyists that are lobbying Congress, both at the federal and at the state level. You don't have trade organizations or conferences around it. So we've got to grow as an industry, and we're really here we're pioneers in this industry, but this technology is really old. The technology was first identified in 1913, so it's 110 years old. Predates a lot of other technologies, catalytic converters, for example. If it wasn't for them, we'd all still be pumping lead gasoline. Anyway, I'm digressing, but it is a proven technology. It does work. If you want a performance guarantee, then we would back it up. That would probably have some implications on costs to the city of Gardner. If that guarantee, we'd have to go and buy an insurance product, and that would be included in the process to you. Everyone that we've talked to is extremely interested in it. We are really running into the capacity issues where 1 or 2 more projects, and then we're going to be at our capacity for the next 2 years, so that even if say Gardner came to us next year and says we want to do this, get in line. You got a 2-year wait before we can get started on you. I don't know if I answered all the questions.
Yeah, you did, Dan. I appreciate that. And that's more reason for us to talk to the city officials and try to get things moving, because I agree with a lot of people in the group. It seems like a no-brainer. Thank you, Dan. Appreciate it.
Okay, thank you, Dan. We have another question from the room.
Hi, I'm Mary Jane Handy. I have a question. Is there a sunset date on that Inflation Reduction Act?
There is, the projects have to begin construction before 2026. There's also, we're coming up on an election year. If Congress was to change, it would require an act of Congress. But if for some reason the Republicans took control of all three branches, I could see them in spite going after Biden's key accomplishments, with the Inflation Reduction Act being one of them. The Inflation Reduction Act has brought billions of dollars in new manufacturing and infrastructure to the United States, primarily in the South. You have billion-dollar battery facilities being built in Tennessee and Kentucky and South Carolina, that I could see them going after Biden's, flagship accomplishments. However, I don't have a crystal ball to know what the 2024 election holds for us, but that is a possibility. And the other one is within 2026, the project has to commence by 2026. The other one is there is a finite amount of money. I believe it's $80 billion in the Inflation Reduction Act for renewable energy projects. Once that money's spoken for, it's gone. So, there's no deadline drop dead date, but, there are things that, need to be considered when evaluating the possibility of Inflation Reduction Act funds and tax incentives for a project like this.
Okay, great. Thank you, Dan. Are there any other questions from the room? Okay, we have another question.
Hi there, Thomas Esposito. Just curious, how many plants have been manufactured since you started up? Do you have an idea?
Total worldwide or by us?
Well, by you.
By us, we're
but
working on.
you're primarily just in. Are you in Mass or throughout the world?
No, we're throughout.
New England. United States.
Yeah,
Sorry.
no, we're headquartered in the United States, but we have projects throughout the world. Right now, we're in the project development phases. So we've got 5 projects going on in wastewater treatment plants in the United States where we have gotten through the engineering design. So the way that the projects typically work, you go through an engineering design. That's where we dial in. Here's exactly those costs. Here's the exact units that you're getting. Then we go into manufacturing. So we're ready to go, expecting to go into manufacturing within the next 3 months or so on over a dozen HTC plants. But right now we have not manufactured any for the U.S. beyond Phoenixville. We're right on that cusp. These things typically have about a 2-year sales and delivery cycle. So delivery being a year, the sales cycle, doing the feasibility study, doing the initial layout, engineering, getting the permits does take some time to do that. And so we're in that phase in Pennsylvania and Massachusetts and Michigan right now. New Jersey.
But I find it odd that if this is such a great existence for towns to subsidize and make money off of, do you have a lot of pushback from other towns and places that say, no, we don't want to bother doing it?
No. In fact, wastewater treatment plants, we have a very high hit rate on ones that engage us, and then ones that have followed through at least to the next steps of engineering and design.
Well, for what you offer and what is given, Gardner shouldn't even be questioning it. It just should be, voted in and instituted to go. It's supposed to benefit the people, the constituents, and the taxpayers of the town, but maybe it doesn't benefit others who run the town.
So I think there's 2 things. One is my experience has been municipalities move extremely slow compared to private industries. So we've had some food and beverage manufacturers that have moved way faster than municipalities have. The other thing is, everyone wants to kick the tires and see everything. And we didn't have the Phoenixville plant operational until basically this time a year ago. So we've had only a year of being able to show people at commercial scale. And in that time, we have, projects in 4 states. But it's not unique to Gardner that municipalities do take some time because you have to go through committees and then there's a formal process that these things have to be decided. I don't think that's a bad thing. I think they do a deliberate process to protect the integrity and to protect the taxpayers. No one wants to do something very quickly and then find out that, oh, well, we forgot about X, Y, and Z, and now the project, is in danger. So that's why they do take quite a long time for delivery.
Unfortunately.
Yeah, but I would say that's not unique to Gardner. It's universal municipal government operations.
Well, maybe we should have the taxpayers do it instead of the people in charge.
Hi,
Thank you,
Dan.
Tom.
Terry.
Thank you, Dan. We have more questions. Oh, go ahead, Terry.
Terry Griffiths again. I have kind of a far-fetched question, but what would the city need in the event of a disaster? The plants seem fairly new, or has there been do you have like a hazard mitigation plan or recommendations? Do your plants come with, if this happens, you need this to deal with it? When you think of gasification, you think of explosions, like how would a town be prepared in such a situation? Should a plant have I don't know what else could go wrong. I don't know what could go wrong, but do you come with, if this happens, do this, and do you prepare the town for that?
So I'm trying to think how best to answer. So let me break this up into 2 parts. So HTC, there is no possibility of things going boom. There is no explosion risk in there. The explosion risk comes with material handling and maintenance done by the wastewater treatment plant operators and employees, right? So if they just have the hydrochar and in the dryer, there's dust everywhere, and they let it build up for years and years at a time, and then that's a fire risk. So we say, here's proper procedures. Whether they follow those or not, again, it's not up to me to be able to dictate what they do. It would be through the operators themselves and the supervisors who are dictating those terms on maintenance and things like that. On the gasifier, you are creating a syngas. That syngas is going through a cold quelch and it's going through an internal combustion engine. The gasification technology has been around for decades. It's no different than lighting a fire in your fireplace in your house. Is there potential that you could burn down your house? Yes. Is it reasonable? No. But we do come with safeguards. So, we have safety things built into the system that it can never over pressurize. We also provide, you would get spill kits. So if any of the material spilled on the floor, you can isolate it. Most of the safety procedures are dictated by state regulations and state codes. So we would always, suggest that the operators adhere to state codes. But by and large, the process is extremely safe. And that's one of the reasons why Phoenixville was so keen to go with HTC. A little bit of background on them: in the early 90s, they had an anaerobic digester. They had an employee do something they shouldn't have done, and it caused an explosion and blew up their digester. That employee survived, fortunately, but he is on disability for the rest of his life. It took them 10 years to get through the lawsuits and get through the insurance claims and to be able to build back their digester. They were getting ready to do that when we approached them about HTC. And that's really what the proving point was: the safety of HTC and the fact that it cannot go boom without severe, neglect and dereliction of duties of the operators, is why they went with HTC over rebuilding their anaerobic digester.
Okay, thank you, Dan. Just trying to see if I can enter somebody else into the room here. They left, I'm sorry. Okay, other questions from the room?
Dan Paul DeMayo again. In terms of this HTC plant, land mass area for it, we talking quarter acre, half acre?
You'd be talking about the plant itself is 5,000 square feet. So you're talking about a decent sized home. Beyond that, you do need about a quarter acre for trucks to come in, turn around, maneuver, haul. That's primarily the biggest driver of space, but we're talking less than half an acre of space needed.
Easily done. Now, in terms of the gasification process, there is residue ash left. With Gardner's plant, what would be the anticipated cubic yards of ash left? And how is that generally gotten rid of?
I don't have I don't have the numbers off the top of my head. I have to refer to the report. It is actually listed in the report how much ash would be produced on an annual basis through gasification. And the typical outlet is that's sold to the cement industry as what's called SCM, or supplementary cementitious materials. So fly ash goes into the cement as a buffer, as a filler, to displace some Portland cement.
Okay, and one more question. Let me think a second here.
One other thing I'd like to point out. Wait, yeah, go ahead.
Yeah, I'm sorry. All right,
Go
Gardner
ahead.
currently has a process where they dewater the sludge. Now, at the level that they dewater the sludge to, would water actually have to be added to the HTC process in order to process it?
No, we wouldn't have to add any fresh water to the system. It would be the water within the sludge that goes in, and that's the water content or the wet moisture content for HTC.
Thank you.
And I was just going to say one thing that occurred to me that I hadn't mentioned tonight is one of the basic features of HTC is you see a volume reduction of biosolids by roughly 75%. So think about it this way. If you had 1,000 tons of biosolids that you were putting in the landfill, and let's say you put in HTC and you're still sending the hydrochar to the landfill, you would be sending only 25% of the volume versus what you're putting now in sewage sludge. So reduction in volume to the hydrochar, and then reduction in volume into the ash. And so you're talking about, again, I haven't looked at the report in a while, but dozens of tons per year, and not thousands of tons of sewage sludge. So theoretically, you could put in HTC and then go put the hydrochar into the landfill, and that landfill capacity, if you took it for 17 years and you put in HTC, you would have then 4 times 17. So you'd have 60 years landfill capacity of hydrochar. Not that I'm saying that's a solution. It's just an illustrative point that it's a huge reduction in volume of material from sewage sludge to hydrochar. It's about 75% reduction.
Okay, thank you, Dan. Other questions from the room? All right. Do we have any questions from anybody else online? If you do have a question, just take yourself on mute. Yeah. I'm waiting just a couple of seconds here. I don't see anybody going off of mute or raising their hand. Okay. Well, Dan, I think you've answered a lot of questions tonight. This is a very good Q&A period. I'd just like to say in closing remarks that there's a tremendous opportunity here. We know that there's a huge supply shortage of disposal for wastewater sludge. All right. But there's a huge amount of wastewater sludge being produced in Massachusetts. And a lot of the facilities that we've seen, and Sue and I have toured these with some folks in the audience like Mary Marsh. We've gone to Deer Island and we've seen what a huge facility that is. It services 43 communities that surround Boston, roughly 2.5 million people of population. There's no sludge landfill around Boston. All right. All the wastewater goes into this facility. Now it goes into a different technology called anaerobic digestion. All right. Produces energy to power the plant. Same concept as this is the result. But also what remains of the digest state is sent to a fertilizer plant in Quincy, bagged and sold. All right. Lawrence has a very similar facility, probably a quarter to 30% the size of Deer Island. All right. What we want in Gardner in this area is we want a Class A solution like that. The uniqueness about what Dan has put together with his team with this HTC technology is scalability. The ability to scale this thing down to a community about the size of Gardner. All right. Now, we would need a little bit of regionalization to make this work, as he's pointed out. We produce about 20% of the sludge needed. We'd need 80% more. But there's, as Viola's executives told Dan when he presented this thing months ago, there is a vast abundance of supply. All right. Greenfield, Massachusetts, about the same size as Gardner, produces 1.8 million gallons of sludge per year. They measure it in gallons because it's really a high water content. They truck it 40 miles from the west of Route 2 all the way past Gardner, another 40 miles to Lowell, where they process it. They spend about 800 and something thousand a year to do that. Okay. They'd love to stop halfway. Sorry, Dan, I'm glad you're back. Yeah. Can you hear me now? I
can hear you now.
We lost bandwidth. I was just wrapping up my speech on Gardner deserves better. We deserve a world-class solution. At least with this solution, again, you got scalability to this size of community. So that's the opportunity.
Yeah. The other thing I would just say is also flexibility too. So this can take in all sorts of material. It could, if you didn't want to haul in sewage sludge, you could fill it up with food waste. You could fill it up with, which, Massachusetts does have an organic waste ban. Manures, other things that can be put into this as well. It doesn't necessarily have to be sewage. We like to call it an omnivore approach. It will eat anything, and it produces hydrochar out the back end.
So let's put in 3 of them.
Yeah, we have one more question.
We use textiles because there's a ban in Massachusetts to use textiles to throw them away.
So we currently have a grant application in with the Department of Energy and Manchester by the Sea to build a mobile HTC unit. It'd be extremely small, 40 liters per hour. But the idea is that is to test out all sorts of different types of materials, including textiles, fish, industry waste as well, from nets to fish scales and eyeballs and things of that nature. So yes, it can, but there's still some more testing that needs to be done before it's ready for prime time. As I mentioned earlier, there's on average over 500 research papers published on HTC on an annual basis from all over the world, not just the United States, but from Europe, from Asia, India, South America, I believe Australia as well. Every continent has published HTC research. And so there are new things coming out every day. One of the things that we're working on, we're not ready to publish yet, but is on recycling of PET, which are plastic bottles. You can put that through an HTC system and get TPA, which is terephylactic acid, and that's the solid. That would be the hydrochar. It's white, which is different. And then it also ethylene glycol. So if you combine ethylene glycol and terephylactic acid, you get PET. So we're basically breaking those monomers down into or polymers down into their monomers. So lots still to be done. But there's over 1,500 research papers on the HTC of sewage sludge. I know that we and Villanova University have published 5 of those ourselves. So the answer is yes, it can do a lot of things. We don't even know the boundaries of what it can do and can't do yet. We're still finding that out.
I know Disney does a lot of recycling for their communities around. And like their plastics, they grind up and they put it in with the concrete stuff.
Mm-hmm.
So.
Yeah, I mean, plastic, as weird as you think about it, plastic actually is carbon sequestration because it's taking fossil fuels and not releasing them into the atmosphere, but, you know, going into solids that take millennia to degrade. Unfortunately, those plastics end up in the oceans and places where they shouldn't. And I think that's really the problem with plastics.
You go to Disney, you don't find cracked concrete in Disney or anywhere in the outside communities either.
Yeah, because at Disneyland, you're not more than 50 steps away from a trash can.
Yeah.
Okay.
They
very
built the
good.
plants with sanitation in mind. So enough about Disney. Thank you all very much for your time. I really appreciate
Yeah,
it.
thank you.
And,
Thank you very much, Dan. I want to also thank everybody for attending. We had a very large turnout tonight. I'd like to thank the staff of the Beagle Club in Gardner. They spent a lot of time with us trying to prepare for this meeting. So we really appreciate everything that they've done. We're going to next look to get this posted online so that you can watch it again and also share it with others. So we'll be looking to do that next. And if you have any follow-up questions, feel free to email them to myself, Alan Russo, at RussoA, ROUSSEAU, letter A, at verizon.net. I'd be happy to get you what you need or forward questions to Dan that he might be able to answer. There's a number of YouTube videos that Dan and his team have done. Those are also educational and some very entertaining, like the Matt Farrell one. So there's other opportunities to learn. And the first step in changing anything, making a change, is education. It's learning. You know, you have to learn about these things. These are world-class technologies. They're just hitting right now. And even though the science is old, 100 years old, engineers and entrepreneurs like Dan are turning that science into an actual process or product that will benefit us. So that's what we have to keep doing, is learning about this stuff. So again, thank you all for attending. I'm going to close out the recording now and hope you all have a great evening.
thank you, everyone.